Okay, good afternoon, everyone. Uh, Thank you so much for taking time out of your busy schedule to attend this webinar. As Gail mentioned, if you have any questions that come up during the presentation, please type them into the chat, and we will definitely talk about all and any questions at the end. Hopefully, we can have a great, lively discussion. So it is just after 1:30. I think we should get started. So during today's online seminar, we're going to be talking about what is turbidity, how can we measure it. We're also going to be discussing some easy maintenance tips, and we're also going to be talking about preventative maintenance. And then lastly, we're going to be wrapping up the presentation with a summary of the key topics that we discussed. So before we jump into the meat of the presentation, I wanted to give a brief recap of what is turbidity. And turbidity is the loss of transparency of a solution because of the presence of undissolved particles. And it's these undissolved particles that cause a scattering of light, and it's the scattering of light that causes this loss of transparency. So that is in essence what turbidity is. And I wanted to emphasize that point because when I first started learning about turbidity, it was a concept that I found a little bit counterintuitive. And so now the next question is, what's going to impact turbidity measurements and what won't impact it? So things like color or dissolved particles don't influence the turbidity. However, undissolved species such as minerals, biological samples, and interestingly enough, the particle size is also going to influence our turbidity measurement. So as you can see here, we have 3 different examples of 3 different particle sizes, and we can see the reflection of the light off those particles varies greatly depending on what the particle's shape is. So this is definitely a key feature you want to keep in mind when you're thinking about how do we measure turbidity and what's going to be impacted. A really nice example from the real world is shown right here, where on the left we have a glass of filtered apple juice. And so all of the particles have been removed and we see that the solution is transparent. Whereas when we compare to the glass of apple juice on the right, the unfiltered apple juice, we see that it's kind of cloudy, and that cloudiness is an example of turbidity, and that cloudiness is the result of there being undissolved particles, parts of peels, little bits of the apple still in that apple juice. So when we talk about turbidity, it can sometimes be a little bit confusing. What do you actually mean when you say the word turbidity? The terms turbidity, total suspended solids, and sludge density are often used interchangeably, but they're not interchangeable and they mean different things. And more importantly, they correspond to different levels of turbidity. When someone says turbidity, a turbidity measurement, they're really talking about, let's make a measurement in a clean water application. And when we say clean water, we want to think influent, effluent, drinking water plants, processed water. Here we have a really low number of solids. When we talk about total suspended solids, or TSS, we're thinking about dirtier applications. There's more grime, maybe some light sludges, and we're looking at solids levels on the order of milligrams per liter to grams per liter. And then when people talk about sludge density, we're talking really, really high levels of particles. We're usually talking about sludges, and we're usually thinking about that as a percentage of sludge. So as you might have guessed from the title of this presentation, today we're going to be focusing on drinking water applications. And we can use our Turbimax, the CUS52D, to measure turbidity in these clean water applications. As a little rule of thumb, if you're struggling a little bit at trying to decide what sensor do I use to measure clean drinking or clean water, you want to think about what is the NTU value. And if your turbidity value is less than 100 NTUs, then this sensor is the sensor for you, the CUS52D. When we think about the Turbimax CUS52D and its accessories, It creates this great package that makes it really easy to measure turbidity in drinking water and processed water applications. Using this sensor and the accessories, we can make measurements like we're in a lab setting. We can have this sensor operate unattended, and this is really important if you have measurement points in remote facilities. You want to have your sensor operate efficiently and effectively all by itself. And then we also have a smart verification tool that helps make the maintenance and that helps make calibrating and maintaining your sensor really simple. Before we jump into more details about the sensor, I first wanted to talk a little bit about what is the measuring principle behind our CUS52D. Here we're using this 90-degree scattering light method, and it's in accordance with the ISO 7027 standard. And this standard is the globally recognized standard for most of the world that we want to be using when we're measuring drinking water. So I don't know if you can see my screen. Hopefully, I don't know if you can see my mouse. Hopefully you can. We have a light source, and our light source passes through to the medium, and then we put our detector. And then we put our detector at 90 degrees from that light beam. And at that detector, we look at how many reflections or how much scattering do we see. And we use this 90-degree configuration because it gives us the best measurement of turbidity when we're in these really low turbidity applications. And you might notice before that I said when we're measuring turbidity, the units are NTU, and this corresponds to this measurement technique. The 90-degree scattering method is also called nephelometric turbidity measurements. So NTUs are nephelometric turbidity units. And when we're using these 90-degree scattering method, our key standard we want to be calibrating on is formazine. Now you might be asking yourself, why use formazine? Formazine is one of the few molecules where we can repeatedly and easily control the turbidity levels through a series of dilutions, as you can see right here. So formazine forms these little spheres, and it very consistently you can replicate the different turbidity levels. One of the problems with using formazine is that it is a carcinogenic material. And so we really don't want to be exposing ourselves and our colleagues to carcinogenic materials. Hence our factory has worked hard to find an alternative to using formazine, but still being true to the NTU method. And before we talk a little bit about how we do calibrations and verifications, I want to ask a question of why do we need to do calibrations during our turbidity measurement? And the answer to that is that we calibrate our turbidity sensors because we need to account for the fact that the light degrades over time. However, with our CUS52D, we have an LED light source, and it's an incredibly stable light source, and the light source doesn't degrade over time. Instead of doing calibrations in the field, our recommendation is to do an annual verification. And our verification tool is the CUI52D. So the sensor comes from our factory and it has a calibration. And then you get your sensor and you want to test the sensor in the field. So we pull out this verification tool. It very easily, as you can see from the photo, just pops on top of the sensor, and then you're going to get some value from a verification unit. And that value is going to be around 4 NFUs. And whenever we use the verification unit with the sensor, you're always going to get the same value. And as long as you're getting that same value, you know that the light source has not degraded and that the sensor is behaving in the way that you expect. So this verification tool really makes it easy to maintain the sensors and be confident that the sensor is working the way you expect it to, and that your measurements are actually behaving in the way that you expect. Sorry about that. I was just checking the chat to see if we had any kind of questions. So far throughout this presentation, we have talked a little bit about what is turbidity, how can we measure it. We've briefly discussed the CUS52D, which is our sensor. We've also talked about the CUY52, which is our verification unit. And then next, I want to talk about the ultrasonic cleaning device. And lastly, we're going to talk a little bit about the flow assemblies. So here is our ultrasonic cleaning device all set up. Here we have our assembly, and the bottom part of the assembly that is pointing down is where the sensor would be, and the sensor tip would be now in the center of this junction of our assembly. And you can see there is the ultrasonic clamp-on. It's attached directly to the assembly. And off to the side, we have our sample collection housing, and this is what generates our ultrasonic pulses. So here's an example of before and after we have used the ultrasonic cleaning in this system. There's a video on YouTube that you can take a look at the following link if you want to see the ultrasonic cleaning in action. And Gail, this is something that we can share with you or anyone who is interested in this. When we look at the before state, we notice that there is a film that is completely covering the sensor, that is completely covering the detector and the light source of our sensor. And so we're getting an artificially high turbidity value. When after the cleaning has been done and that film has been removed, we can see that our turbidity value is much more consistent with the clear water solution that we're seeing. A really important point about the ultrasonic cleaner is that we really want to be using it as a preventative system. We don't want to be using it to remove a film, but instead we want to be preventing a film from forming on these sensors. And so you might want to use the ultrasonic cleaning device if you have turbidity sensors in a remote plant. You know, if you have a couple of remote locations and they don't have very many traffic, you don't have a lot of maintenance going out to them, then an ultrasonic cleaning device could be a really good idea to help you maintain the health of your sensor so that you can feel confident that the sensor is behaving the way you think it is, or the way you want it to be behaving. So we also have this pressurized air as our second option for preventative cleaning. Here we can see that we have our sensor and we have our air cleaning unit has been attached to our sensor, and again we can see the sort of before and after the air cleaning has been applied. I want to draw your attention to the bottom right hand corner. And I want to point out that you can see that the air jet head is slightly offset from the actual light source and detector of the sensor. And this was done by design. Here we have it so that the air cleaning is blowing over the sensor, but is not blowing directly onto the detector. If the air was blowing directly onto the detector, then that would cause false turbidity values and would cause a lot of confusion with our measurement. So we've worked really hard to try and make this easy and simple for people to use, and to maintain a good measurement integrity. Now the air cleaning can be used when we have our sensor in an immersion style measurement. And for the air cleaning, we have to have at least one relay in our transmitter. And once you have that one relay, it's all part of the standard features of our transmitters. So another problem that sometimes comes up is bubbles. And so we do have a technique for dealing with bubbles when that is an issue. Here is our bubble trap device, and we see that the air, we see that the water comes into the bubble trap, and we see that there's a little bit of a centrifuge, and the water and the bubbles travel through the centrifuge, and then all of the bubbles are then forced into the center of the chamber, and then they're pulled out from the recirculation tube. Now, here in North America, bubbles and bubble traps aren't widely used. Most of the time, the bubble trap is needed more for European applications, but here in North America, since we're typically doing an extraction type sampling and we're dumping to drain, we have found throughout our testing that we've done across the country that the bubble traps typically aren't needed, and the odd time we have seen bubbles, it's often been a process-related problem. But when bubbles are a problem, this bubble trap is very effective at removing the different bubbles. As I mentioned, I also want to talk a little bit about assemblies. And here's an example of an assembly where we're doing an extraction type measurement. And you can see here's a real photo from a customer site where we have our sensor in our CUA252 plastic assembly. And I want to point out that we have this tri-clamp connection. And the tri-clamp connection is perhaps a little bit surprising to some of you, particularly those in the municipal world. And the tri-clamp connection was selected as in Europe, water is considered to be a hygienic food, and the sensors were designed to be hygienic. And so this actually has an added advantage of when you have a tri-clamp connection with this CUA252 assembly, it makes it really easy to do cleaning. And so when you want to do maintenance on your sensor, you just remove the tri-clamp connection, you pop the sensor out, you wipe it off, and then that's it. You put it back in the holder, you put the tri-clamp back on, and you're back to measuring. And so this is what I was saying before when we were talking about remote installations. If you have lots of traffic and lots of people coming by your measurement points and you have a tri-clamp connection, you really don't need to use the ultrasonic cleaning because the maintenance is so simple and so easy. We've had a number of customers comment on that. That's one of the features they really liked about these sensors, how easy they are to use and maintain. But to reiterate the point, if your sensor's in a remote location that's not going to be visited very often, and you want to do preventative maintenance on it, then the ultrasonic cleaner is a really good way to make sure that we're not building up gunk on the sensor, that it's behaving accurately, and helps us feel confident in the measurement quality that we're getting. As many of you might know, the turbidity sensors are not the only analytical sensors that we make. We have a whole wealth of different types of sensors. We make pH sensors, dissolved oxygen, conductivity, and including turbidity. And because of the nature of the platform and because of the nature of how our devices are set up and the platform we have, you can take this transmitter. You can take the transmitter as you see here on our panel, where we have our transmitter, our turbidity sensor. But if you had other measurement points you wanted to make at that installation, you could also connect a chlorine sensor. You could also connect a pH sensor or a dissolved oxygen sensor. With our transmitters, due to their unique design, you can expand the transmitter so that you can make the number of measurements that you want. You can add up to 8 different sensors to this one transmitter. So when we're thinking about installations and making measurements, yes, today we're talking about turbidity. You buy a turbidity sensor, you input it, but you realize, oh, a couple years, a couple months down the road, I also want to measure chlorine. That's not an issue, and we can easily connect the chlorine sensor to the same transmitter. So you have a really small footprint at your installation site. So to summarize some of the key things we talked about during this presentation, we talked a little bit about what is turbidity and how do we measure it. We talked about the CUS52D Turbimax sensor and its accessories. The sensor is designed to be compliant with the ISO 7027 standard, and we can easily measure turbidity in clear and clean water. Another important point to think about is that the accuracy is independent of the installation environment. We talked a little bit about the verification tool. So when you are using our verification tool, as you can see here, the sensor just easily pops into our verification tool, and you can now quickly do your verification. Our recommendation is to do this once a year, and that's because our light sources are very stable. With this solid state verification tool, there's no more need for using dangerous and harmful formazine. And because we're verifying the sensor, we have a stable light source, you can have confidence in your turbidity measurements. And lastly, we talked a little bit about how we can help you with your unintended operations. We can help eliminate bubbles. We have we have a couple of different options for helping remove the buildup of biofilms on the surface of your sensor. So that can be done with either the air cleaning or the ultrasonic cleaning. And this is a really great benefit to really prolong the intervals between your maintenance. So you don't have to spend your maintenance budget taking care of these sensors. Instead, you can do other tasks. So thank you very much for listening to the presentation. Does anyone have any questions or thoughts? Or I'd like to ask the audience, maybe someone can talk a little bit about their current experiences with turbidity.
All right, hi Zoe. So we do have a couple of questions.
Oh, good, good. Okay.
All right, so the first one I've got here is EPA approval a global requirement for drinking water, or is it only a US requirement? With the CUE21 phased out, what is E&H's plan for EPA approved measurements in drinking water plants?
So that's a fantastic question. And the EPA regulations dictating that white light is necessary, that is only a requirement in the US. And it was very unfortunate that the CUB 21 and 22 were phased out quite a little bit abruptly, but the factory is looking into alternatives, and they're exploring a new white light turbidity sensor and are currently in the process of getting it EPA approved.
Okay. Let's see. We have another one here, Zoe. Is it an easy modification to add air cleaning? Shoot, I'm so sorry. When the sensor does not originally have it.
Yes, the air cleaning can definitely be added after the fact. So you just add the actual air cleaning unit to the sensor, but the important part is to make sure that you get the relay on the transmitter. So either that means you need to order your transmitter with the relay cleaning option. If you didn't order that feature on your transmitter, that's definitely something that can be added to the transmitter after the point of sale.
Okay, I've just sent another question to you, Zoe,
Oh.
in your chat.
Here we go. Maybe you can read that to me. I'm having a little bit of trouble seeing the chat.
Okay. Does the CUA252 impact the measurement? I see that you have a vertical orientation for the panel setup.
I'm sorry, Gail. Can you repeat that?
Of course I can. Of course. Does the orientation of the CUA252 impact the measurement? I see that you have a vertical orientation for the panel setup. Okay, did you get that, Zoe?
I did get that.
All right, I'm going to send it to you so you can see it written up. It might be easier.
No problem. No problem. So, does the orientation impact the measurement? So that's something we can check out and get back to you about that. So Gail, if you have the name of the person, we can reach out afterwards. But one thing to note that is important when you're initially commissioning these sensors, it's important to state what holder you are using, because we need to account for the assembly and during the commissioning setup, because there will be reflections from the different assemblies, and by adding in that assembly factor, you now remove any background noise from that assembly. So yes, the orientation probably does impact it, but we'll confirm and let you know.
There was another question that I put in there for you. Okay. I can read it for you, Zoe. If it
maybe you can read it. I don't seem to be seeing the questions. So
okay, are there plans to have an EPA 180.1 drinking water approvals added to the sensor?
As far as I'm aware of, the current focus is looking at getting a white light turbidity sensor EPA approved with the 90 degree scattering. But I can, we can reach out to the factory and see what's on their roadmap and get back to you.
Okay, another question that I have here is, have you changed the bulbs on the new sensors?
Are they, when you say new sensors, are you talking about the CUS52D?
That's all that I've got for the question. Hang on, I'm just going to unmute the audience.
Okay. So as far as I'm aware, the bulbs for the CUS52Ds haven't changed since this product was launched.
Sorry, Zoe, you couldn't hear me. So I have another one.
Okay. That's okay.
Calibration should be conducted by baffers or by a number of samples?
So,
sorry, buffers, by buffers. I'm sorry. Yeah,
so
calibration should be.
No problem. So when we talk about calibrating turbidity sensors, it's not quite the same as calibrating pH electrodes, and I'm assuming that's where this question is coming from. When we calibrate pH electrodes, we're actually, we use typically two or three different buffers so that we can make correct adjustments to the pH response we're getting from the sensors. But with these turbidity sensors, we don't have to make calibration changes because of how stable the light source is. When we think about turbidity, we want to, and typically when you have a white light source, we need to be making regular calibrations because that white light source degrades over time. With our CUS52D, we have a very stable LED light source. And because that light source is so stable, we don't need to make adjustments to the calibration that the sensor got from the factory. Instead, we recommend using our verification tool. So let me just jump back. Oh, here we go. Just let me jump back to the slide that talks a little bit about verifications. So let me move something. So when we are using our verification tool, we have this solid state tool and it just pops onto the end of the sensor. And when we look at the output of the sensor, we're going to get some value very close to 4. And when I say some value, it's going to be 4 plus or minus 1.5 NTUs. And that specific value depends on the combination of the light source and that reference unit. And every time and you want to write down what that value is. Let's say it's 4.1. And every time you test the sensor with that verification tool, you should get the exact same value back. And if you keep getting that same value back, then it tells you that the light source is in fact stable and the light source hasn't changed, and so no calibration is needed. Does that answer your question? I don't know whoever asked that, if they want to unmute themselves and we can chat a little bit more about this. Or, feel free to reach out to us and I can definitely give you a call and we can further discuss the verification and calibration concepts for pH electrodes and turbidity sensors.
Okay, Zoe, that looks like all of the questions that we had in the chat box.
Okay, excellent.
Okay, well,
before we sign off, does anyone have any other questions that they'd like to ask?
No, I haven't seen any more questions come up, Zoe. Well, I would like to thank everyone for their time in coming out to listen to Understanding Drinking Water Turbidity with Dr. Zoe Reeve. Zoe, if there's any additional information you'd like to pass on, please do so.
So I'd like to echo Gail's statement of thank you so much for taking the time out of your busy day to come learn about turbidity measurements and how we can help you make those measurements easy and safe. And once again, thank you.